Okay, so with less than, when we had absolute value inequalities with less than, we had the less than sandwich. But greater than is different. So if you had something like the absolute value of x is greater than, I'll put or equal to 5, then certain numbers will, maybe make sense. So here you are at 5, and then 6 and 7 and 8, and all those numbers are going to work because if you take their absolute value, you're going to get an absolute, or you're going to get a value greater than or equal to 5. Absolute value of 6 is 6, absolute value of 7 is 7, so on and so forth. But there's another piece that will work. So it's down here. If you had negative 5, okay, you could use that. That would work, right? Because the absolute value of negative 5 would be 5, and 5 is less than or greater than or equal to 5, so that works. But see, negative 6 works because the absolute value of negative 6 is greater than or equal to 5 because you get 6, and 6 is greater than or equal to 5. So what happens is we get all these numbers that are smaller than or less than or equal to negative 5, okay? So you get two pieces going on. It's kind of a divergent thing. You get one piece going this way and another piece going that way. Now the numbers in between don't work. The absolute value of 1, that's not greater than 5. The absolute value of negative 1, that's not greater than 5. So it's just these two pieces that work. And so what we get is we get x is greater than or equal to 5, and x is less than or equal to negative 5. So it's the tricky part. It's like there's two changes. You're switching it to less than, and you're making it the negative case. And this is an or situation where you have one or the other. So I don't know if that says or, but or. So, and you write that in interval notation, it would be from negative infinity up to negative 5 with a bracket, union, bracket 5 to infinity. Now we're going to do some examples so you'll see this, but that's what it is. So now here we have an example. Graph the solution and write the solution in interval notation, and we have the absolute value of x is greater than 2. So you're going to say one piece is x is less than, just less than 2, negative 2. Negative 2. So that's the double change. It's less than the negative case. Or x is greater than positive 2. Okay. And so the solution looks like this. Here's 0, here's 1, 2, and negative 1, negative 2. And so it looks like parenthesis. I almost made a bracket from the last example. Parenthesis that way, and parenthesis that way. And so what does the interval notation look like? It looks like negative infinity, I forgot the parenthesis. Parenthesis, negative infinity, comma, negative 2, parenthesis, union. And when you make that union sign, it's not a U, it's just, it kind of looks like a U, but it doesn't have like a little tail on it. And then parenthesis 2 to infinity. And that's going to be the interval notation right there. Okay? So really big numbers are going to work, and small numbers, smaller than negative 2, really small numbers that are less than negative 2, those are going to work. Okay, so now we have another example that's a little more involved with the inequality or the absolute value part. So what we're going to do is we're going to take the absolute value part, 4x minus 3, it's already isolated, and we're going to set it less than or equal to negative 5. And then we're going to take, and this is an or statement. And a long time ago, one of the math teachers said, I tell my students to remember greater or. And I've always remembered that, so I don't know if that helps. 4x minus 3 is greater than or equal to positive 5. So you have the two cases where one's going this way, bigger than 5, and the other's going this way, less than negative 5. Okay, so then we have to solve these. So add 3. And I get 4x is less than or equal to negative 2, divided by 4. And I get x is less than or equal to negative 1/2. So that's part of the piece. And then add 3, I get 4x is greater than or equal to 8. Divide by 4, divide by 4. X is greater than or equal to 4. Oh, I wrote that wrong. Darn it. Okay, back up, back up. Wasn't a 4. I didn't divide by 4. I put 2 in there for some reason. I think I was thinking ahead. Okay, x is greater than or equal to 2. Okay, that looks better. All right, so how do we graph it? Well, here comes the graph. So we have 0, 1, 2, and over here, negative 1/2. So negative 1/2 is going to be like right there. And these are equal to's. You don't get to pick whether it's equal to or not. They give that to you in the inequality when they give it to you. Okay, so we'll be using square brackets. So square bracket at 2 going this way to the right, square bracket at negative 1/2 going this way. Now the fact that those are opposite reciprocals, that is just a fluke. Don't know why that happened, because I've seen other cases where they're not that way. So, okay, how do we write it in interval notation? Well, it follows the graph. So negative infinity to negative 1/2 with a bracket, union 2 to infinity parenthesis. And that's how it looks.